Hello, Mr. Stone here, and today we are going to be looking at t-tests. So imagine, if you will, for a moment, that your friend is willing to sell you this autographed picture of movie star Tom Selleck. And it looks really cool, and it is quite awesome, but you're wondering, is it really worth $100? Is it worth that money from you? So let's see if the claim is valid. We've got a claim of that the photo is worth $100 on average. And let's say you take a sample. So our sample is denoted here by N. So you've taken 8 samples. So you've looked at the price of the picture 8 times, and from those 8 times you're able to draw an average of just the sample, that's our X bar, of $95.2. This sample you have also determined by looking at the standard deviation is 10.5. It has a standard deviation of 10.5. Well, let us create some hypotheses. Our null hypothesis is that, hey, this photo is indeed actually worth $100. Our alternative hypothesis is, I don't know. I think it might be worth a little bit less than that. We're going to use a T-score in order to determine if indeed the average price, the mean price for the photo over really all of general time here is $100, or if it's less than that. So for starters, we need to look at a few things. We have a way to get our t-score here, which the formula looks kind of familiar, similar to our z-score, but again, we don't know the standard deviation for the whole population. That's our sigma. We don't know that. We're going to have to go off of our sample. We get everything from there. So to get the t, we need to get x bar, which we've got mu. We're going to plug in our hypothesis value for mu, so we've got that. But we don't have this standard error down here. We don't have that yet. But we can get that. Hey, the formula for that, I think we know this one. The formula for standard error is your standard deviation over the square root of the number of items in the sample. So we can figure this out. We go back up here. I said, aha, I've got a standard deviation of 10.5, and my n was just 8. So I've got 10.5 over the square root of 8, and that gives me 3.71. Okay, now I can take this and I can use my standard error, plug it into here. We already said that the x bar is 95.2. So I plug in 95.2 minus, I'm going to plug in 100 here because this is the mu from our null hypothesis. This is what we're going to lay for our initial claim. And then we just determine the standard error, which is 3.71. Do all the calculations on this, and you should get negative 1.294. Okay? And this is your t-score right there. Now, what does this mean? We're going to need to think about this visually for a moment. So I've got a t-distribution here, what this looks like, and I know that I've got a sample size of n. Okay, my n equals 8. Therefore, for this one sample t test, I've got degree of freedom of, that's just n minus 1. So n minus 1 would give me 7. So I've got 7 degrees of freedom. I'm going to look at my t-score chart. And what I want to do is I want to get a probability of 0.05 over here that it is indeed less than the population mean, my sample mean, that is. So I look up 7 degrees of freedom combined with a one-tailed. Notice I'm only looking at the left right now. I'm only concerned about less than. That's my alternative hypothesis. My alternative hypothesis was that mu is less than 100. So I'm looking at it going off to the left. That's why the 0.05 is over here. So in the center here, I would have 0. That's my mean, where my mean would be. And I'm looking at my T-score chart, and it tells me that if I want a one-tailed, this is one-tailed because it's only going off to the left. If I want a one-tailed probability of 0.05, and I'm still looking for my degrees of freedom of 7, I can cross those two, and I should get a value of where t is 0.05. The chart just tells me that it is at 1.895. Now there's one more thing that we need to think about here. We're looking at less than. So again, we're thinking to the left. So this is going to be less than 0. So we're not going to use 1.895. That would put it somewhere over here, and we really don't want that. We're going to change this to negative because it is to the left. So my t value for this point right here, this divider, is negative 1.895. Now, that's the marker. If I go beyond this, that means I'm in this 0.05. In that case, p would be less than 0.05, and that tells us something about our hypotheses, that we would reject the null hypothesis. Our t-score, however, was negative 1.294. So negative 1.294 is going to be somewhere maybe about right here. Negative 1.294. Okay. We don't know exactly what the probability is at that point. There is a way through some technology that we could, but all we're really concerned with at this point is that this is to the right of negative 1.895. This is where area down here to the left would be where our probability is 0.05. So in this case, we've got p is greater than or equal to 0.05. That's why it's over there. Therefore, since p is greater than 0.05, we go back up to our hypotheses. P is greater than 0.05, so we do not reject our null hypothesis. And you know what? This is probably worth the photo. Probably worth $100. So it might be a good investment for you. All right. Watch Magnum PI. It is a fantastic television program, and Higgins is awesome in that as well. Let me know if you have questions, and have a most excellent day.